like Iain was mentioning, that there's a lot of different news articles that are perpetuating racial stereotypes without realizing it. And if you think about it, we're exposed to so much media, news, fake news, bias, and so much content on an hourly basis. It's really inherent in everything that we're reading and everything that we're seeing. And could this be the reason why there's this perpetuation of hurtful ideas and biases? And so I just wanted to set that tone because this is how we all came together to work on this project. We started this project about a year ago with the murder of George Floyd, and this was really how we came together as a team. And we were often humbled by those who were sharing the background on the use of certain words and phrases. And on a personal level, we saw a need to educate ourselves and bring awareness to question our own biases in the content that we've either created or consumed. And so this project is really an outcome of us coming together and seeing this opportunity to address bias detection in the media and, like Iain had mentioned, educating people in the process. So on the right here, you see that there's a bunch of different headlines that share the significance and the need of something like TakeTwo. Some of you may be aware of the movement that a lot of tech companies are taking with having that serious look at what kind of terms are we using within code and projects that may have the background of having racist implications, and definitely taking a closer look at how the content in social media perpetuates racist stereotypes without people being aware. And the influence that the media has is not really a new thing. So it's really powerful to understand the background of the words and phrases that we choose to say and continue to say, and that's really underscores the premise of our project. And so we really believe that awareness is the key, and we think that bringing awareness to when the use of language is racially biased and why this could help mitigate content that is created from just people not being aware and not knowing. And therefore, this could minimize bias that's perpetuated through the content and hopefully then, in turn, reduce the amount of offensive and hurtful content that's out there. So that's kind of the background on how we came here. So we initially began with the idea to build a tool that would detect bias in content. But we quickly realized that there wasn't a publicly available data set on this at the time of the project. And so, this made sense. Their language is incredibly subjective, and while it's more straightforward to identify overt forms of racial bias, it's really hard to capture those more subtle forms. And so we began with an API that we wanted users to be able to leverage to check their content against our machine learning model. And the API, the goal of this was that it would highlight content with an explanation as to why it consisted of racial bias. But this really is underpinned by our machine learning model, which Naoki and Preetika will go into a little bit more detail. But we needed data for the API to check against, and at the time we didn't have that publicly available data set, and so we thought a good idea might be to leverage the community in order to crowdsource this data, and that's really how our idea of having a browser extension connected to this came into fruition. So the thought is that we would have community members, trusted community members, be able to identify examples of racial bias within the content that they're reading, and this in turn would feed into our data set, and a machine learning model would then feed into the API that would then flag these examples of content and explain to people why. And so that's the basic premise of our project. To be clear, we understand that this is an extremely complicated task, depends on context. We don't really have a ground truth, but I think we all think that we've set up a great starting point, a good foundation to explore these ideas further and really contribute towards helping educate people. And one key thing to note is that our entire experience here is intended to be private, and so this just underscores back to our goal is to educate and empower people to understand what they're saying, and also empower people to share ways in which when they find content offensive, and explain as to why. So that's an overview of our solution, and I'll pass it over to Johanna to explain a little bit more about with the solution architecture and dive into the demo.
Hey, Naagma. I don't know if you can see this, but under my name it says that my name's Upcar, but my name's Joe. I don't know if you can see the same thing, but hopefully you can hear me. So this is just the solution architecture of what we kind of started to build. There's definitely more work that kind of needs to be done on it, but essentially we have this, so where you've got number 1 and 2 is called our TakeTwo marker, and what this is it's a browser extension, and this is basically to solve the problem that Naagma was talking about a minute ago, which is that currently there are lots of sources of data for overt racially biased language, but when you're dealing with more subtle forms of racial bias, there isn't a kind of public data source available. And what we wanted to do was have a kind of open data set that could be used not just by our project, but also anyone else who wanted to do research into racial bias, and something that could be community owned rather than privately owned. So what the TakeTwo marker does is it allows someone to capture language that they feel is might contain racial bias, and they can flag it. And there's also the possibility to categorize it. And we, as a team, came up with, I think, 5 or 6 categories of racial bias. But again, these are open to change as and how the community deems necessary. I will demo all of this in a minute, as long as I can share my screen. So in the middle sits a TakeTwo API, which basically does a few things. It puts the data that's captured by people using the Chrome extension into a database. It also feeds a client tool, which is basically a text editor at the moment, where someone can type text into, which we also hope to eventually develop into a browser extension, so that someone could be on social media and toggle it on or off. It also is where it connects to the machine learning model so that it can serve back the result basically to the client. So if someone has written a news article or a social media post, they can type it. It will use one of the endpoints that we've defined in the API, which reaches out to the ML model to get basically a decision on whether any of that contains potential racial bias. For the purposes of the demo today, I'm going to just show the API, the Chrome extension, the database, and the client, mainly because I don't want to sort of show sensitive language in this presentation, but I'll explain exactly how to wire it up so it connects to the ML model instead. I'm going to share my screen. I hope this is going to work. Yeah, so Naagma, can you see this?
Yes. Yep.
Yeah.
So basically the Chrome extension for now has this little logo on it, but that's probably going to change. So obviously we built this for a project called Call for Code, which is a very short, kind of intense problem solving challenge, which was on this occasion within IBM. And so we built kind of the main components, but now that we've open sourced it, it's kind of open to external developers and ourselves to carry on working on it. But basically, this is a plugin, so you can log in. I should already be logged in here, and you can authenticate and it authenticates against IBM App ID at the moment, but you can switch it for any authentication system that the project would want to use. Or we've also talked about it not being authenticated. The nice thing about people logging in is that we can understand how valuable they are as contributors. And it also might be that we want to stop people who are sort of putting malicious content in there and identify them. And they're identified with a sort of unique identifier that is anonymous. So once you've got this installed, you can go to any web page and you can turn on your highlighting cursor and you'll see this small pencil. So this is basically people who are contributing to our open data source. This is completely anonymous, so they'll log in privately in their own browser. And this is just where we collect data for the data set. And the back end is a CouchDB database, which I can show you in a minute. But basically, they can highlight any word or text. And obviously, I'm not highlighting things that I really think are racially biased, but just to give you an idea. And they can categorize it. So we've built these categories in. And I guess it's up to the project if they want to use them or if they want to just classify something as racially biased or not. What we've done so far with our machine learning work is we're just doing yes or no. So racially biased or not racially biased. We don't have these categories built in yet, but that would be something that we'd be looking to do next. You can also highlight entire sentences. And this all then gets collected and is put in this backend database. And this is a CouchDB database, which I've currently got running in a container. I might need to log in again. Let me just log in again. And this is basically any of the contributions that I've made as a user. And obviously the project itself, so we are looking to get the data hosted by a kind of impartial organization. So this will be something like a university or a charity or somewhere that is a kind of trusted impartial source, because obviously this data could be quite sensitive and we ideally don't want it to be held by a private organization. We want it to be free and all in the open. The fast API, so this is all on the API is all built using fast API. I should say the Chrome extension is built using JavaScript. There's all different endpoints. So the categories are all defined in the API itself. So they're not defined in the Chrome extension. So that makes it easier to adapt them. You can, so to use the API at the moment, you need to be authorized. I think I've logged in already, but basically then you can see, you know, this one will get you everything that's in the database. Post, sorry, I'll just collapse this because it's a bit confusing. So post mark is where you can put a mark into the database. Delete mark is if someone goes and chooses the bin. You can also change, which uses the put mark. So that's where you can change contributions you've made. This is to get the categories, and we've also got an analyze text endpoint and a check endpoint, and they're basically used for different things. So analyze goes straight to the database and checks from against the machine learning model. So at the moment, I've got a text editor opened with just connected to the backend database. So I'm just going to go back to Chrome. So what I've got is it's just connected to the database at the moment. So this is basically the client tool. So ideally we want to have this as a browser extension, but for now it enables someone to come along and say and type something that they want to post on social media. So and then they can check their content, and then obviously this should be connected up to the machine learning model. In this case, it's just connected to some words that I've randomly selected today. But basically that's kind of how it works. And I think that's pretty much it. So I'm going to stop sharing now, unless someone wants me to show something else.
No, I think that's perfect, and we can dive deeper into the machine learning piece. And I'll let Naoki take it away.
Okay, can you hear me?
Yes.
Okay, great. Yeah, so I'm going to say a few words about the machine learning component, several methods that we have envisioned, and then later Pritika is going to take you through some concrete examples. So we have a version of the machine learning component implemented in the repo, but beyond that, we have sort of a vision and a roadmap for where we want to take it to. So starting from the left, which is more basic, and then going to the right is more and more sophisticated. The version 0, what we call it's really not a machine learning one, but it's sort of a dictionary lookup. But starting with that, version 1, the next one, that's the one that we have implemented in the repo. And it builds a machine learning model that can detect racially biased terms or expressions in context. And for this, we are using some classical machine learning techniques like simple vector machines and bag of words representation. We are aware that we need to take it further to really take into account the most sequential and detailed context in text. And so for that, for version 2, we envision that we'll leverage the cutting edge deep learning kind of techniques. Version 3 is where we not only detect long paragraphs and sentences to be biased, but we also are able to pinpoint to exactly where in those large chunks of text the bias lies. So that would be the third version. The fourth version is where we want to address the issue of credibility of the markers in our crowdsource setting, where you want to actually learn the credibility of the markers and make use of that information to improve the models. And eventually we want to make use of that sort of information to do active learning, where we solicit labeled data from more credible markers. So in what follows, I'd like to say a few words about 3 of these versions. The first one being version 1, the bias expression learning in context. And as I mentioned, we make use of some classical learning methods like SVM, naive Bayes, and bag of words representation taken from the scikit-learn library. But the important thing is that this is the machine learning model is trained with labeled examples of the form expression classification pairs. And then it learns to classify given expressions. So the picture on the right depicts how this works. As training data, it's given a large set of sentences or paragraphs, each labeled with, in this case, biased and unbiased. And it transforms then the texts into bag of words representations or some extensions thereof, which are like word counts, and then train classifiers like simple vector machine and naive Bayes classifiers in order to separate the biased and non-biased texts. And then when a new sentence or paragraph comes in, you do the same transformation and then you apply the classifier to then come up with biased versus unbiased kind of judgment. So this is version 1. If we can go to the next slide, this is sort of the next one, well, version 3, that will build on top of this version or the deep learning variant thereof, where, as I mentioned, you would receive and train a model using text classification pairs, and then you make the biased, unbiased judgment on the text as a whole when a new text is given. But you also can pinpoint to what part of the text lies the causes for the judgment of biased versus unbiased. So that's shown in some concrete examples on the illustrated examples on the right. It not only can judge this whole sentence to be biased, but it can point to certain problematic parts of the text. So this kind of thing is often referred to as explainable AI or explainable machine learning models. And there are some libraries that do this kind of thing, but much more often on the standard tabular data. So on this kind of textual data, I think some extensions of such methods will be needed. And that's another place where we need to make more progress. If you can go to the next slide. So this one is a slide about the version 4, which we call Ensemble consensus learning. And as I said, this is to counter the issue that some of the, in the crowdsourcing setup, some of the markers might be less reliable, or they could even be, possibly adversarial. But so even though we're given labeled data, we don't have 100% confidence on them being ground truth. So that's kind of a tricky situation to deal with. So we are proposing a specific approach to deal with this, and which is called Ensemble consensus learning. And it builds on the theory of what's called in the literature ensemble learning. So ensemble learning, many of you may be familiar, but basically what it is that you create many machine learning models, an ensemble of models, sometimes using multiple machine learning algorithms, or sometimes just with one, the same algorithm, but applied on different data sets. And then when you obtain an ensemble, you make the final prediction using, as shown here, essentially averaging or taking weighted average of the predictions by the many models in the ensemble. Now, in a classical ensemble learning method, you then try to learn the importance or credibility of these different models by aggressively punishing models that make mistakes. So this learning update formula that's shown over here, that's updating the weight of an ith model by multiplying it by a number that's smaller than 1 when it makes a mistake. So it's known in theory that this kind of method can very quickly converge to the models that are performing well, and then weed out the bad models. But one challenge, as I mentioned, is that we don't really know the ground truth. So here, when you judge whether a particular model makes a mistake or not, we appeal to the weighted consensus or weighted vote of the current ensemble model as the pseudo ground truth. So that's why we call it ensemble consensus learning. We're trying to punish outlying models that deviate from the ensemble. So with some reasonable assumptions, one can show that, or hope to show that this, also will fairly quickly converge to the right or the good models. And so how do we apply this in our present context, where we have many markers and some of them unknown ones are less credible? So we do this by taking many subsets of the set of markers and using those subsets of data from those subsets of the markers. We train many models corresponding each one corresponding to a subset of the markers. And then you go through this ensemble consensus learning, and automatically this mechanism can weed out the models that are built on bad subsets. And because if you draw enough random subset of markers, you can be sure that some of them are free of unreliable markers. By doing this, you will zoom into the more credible subset of the markers kind of automatically. So this is sort of another future version that we are envisioning. And as you can see, there are more future versions than the the current one, and this is why we want to recruit and solicit people with machine learning and AI kind of background and interest to join this cause. So in what follows, Pritika, who's been doing some very cool machine learning modeling work using a specific public data. She will explain some more interesting aspects of our initial modeling efforts. Okay, with that, Pritika, you want to take over?
Yep, thanks, Naoki. Hello, everyone. This is Pritika. I'm going to talk about some of our initial modeling efforts, like Naoki said. And just to let you all guys know, I am the newer addition to this amazing team, and it's a great team to work with. So we are super happy to have any of you on board with us in future. Well, so when, as you know, the objective was to get an AI model developed as we progress to our next phases. And the first question was, where do we get the data set from on which we can train and test? So fortunately, we were able to find this data set called Jigsaw dataset from Kaggle platform. And the slide which you're seeing is some of the initial exploration which we did with that data set. So this data has about 1.8 million observations. It has textual comments in it. People generally make comments, so it has a collection of that comments. It has associated categories of potential discrimination. For example, it has columns like, is a comment potential discrimination for a particular ethnicity or for a particular race or a religion, like that. There is another column, which is toxicity severity. It is a numeric column, which is between 0 and 1, 0 being a comment which is fair or a straightforward comment, 1 being a racially biased comment. So we looked at this whole problem from the lens of classification first. So we have converted this severity toxicity column into a binary column, which where 1 stands for any comment which is severely toxic. And the chart which you're seeing on top left with pink bars, this chart represents the relative count of these different comments and how do they belong to each of these discriminatory categories. And this was subsetted for severely toxic comments. So you can see that it starts with gender biases, followed by religious biases, and then followed by ethnicity and race. Talking about the charts on right-hand side of the slide, which you can see four different charts. So this was an attempt to understand how does certain words which we like in our day-to-day life, which we think are bad words or racially biased words like that. So we divided our whole corpus in 4 categories, where category 1 was fair comments or simple comments, where category 4 was severely toxic comments. And then we wanted to see how does the word frequency of these selected words, how does it look like? So the F word, right? I'm not going to name it like Iain said in the beginning. Some of the words we've star marked, some of the words we've blurred out, but you all should be able to understand most likely. The F word, we saw that as the word frequency is increasing, the severity, the toxicity severity also blows up, it increases. Same was the story for N word. Whereas some of the words like pig or dog, which is not necessarily, it could not necessarily mean that it's a racial slur. We saw that the frequency of those words, they took a dip for some of the highly toxic corpus. But eventually, if the corpus is very, very toxic, the frequency of these words is up again. The inference which we draw from these charts is some words can be a good or an absolute indicator of a toxic comments like F word or so on. Whereas some words like dog, sorry, pig, these words, they can be or cannot be toxic, but context is important when we want to classify with them. So this hints us that we definitely need context-based learning going further. Next slide, please. Okay, so this is some more details around the specific machine learning algorithm which we used. We used support vector machine classifier. We also experimented with some others, but this was the best one so far we got. And we used TF-IDF features from our data set to make it. To those who are not familiar with what is TF-IDF, I can elaborate a little bit. It's a statistical measure. It is mathematically, it is a product of frequency of your word multiplied by inverse document frequency. Inverse document frequency, as you can see, is the logarithm of total number of documents divided by number of documents which contain a particular word. So this TF-IDF is calculated for a particular word in a particular document. Now you can think that words which are very common, like is, and, the, of, they will have a relatively lower TF-IDF score. But words which are relevant of the document, or which are not very commonly occurring, but still they have an importance in your document, that will have relatively higher TF-IDF value. So this brings the essence that how relevant your word is to a document, and that was the whole purpose of using this metric. Some of the steps which we used to train our first model, standard steps: we cleaned the data set for punctuation, white spaces, we removed the stop words, we did lemmatization. Lemmatization stands for words like running and ran. It will be translated to its root word, run. This data set was very imbalanced, and you can obviously imagine, like, there was only a chunk of comments which were severely toxic. So we had to perform downsampling to get fair results, and we downsampled non-toxic observations to about 6%. We generated TF-IDF vectors, and then our data set was ready to send to an optimization algorithm to start the training. And we chose, like I said, support vector machine for our training. We used SGD classifier class from scikit-learn. We also optimized the hyperparameters coming with it using the grid search cross-validation. So you can see in the table on right side, on the right side, all the standard metrics of a classification models like accuracy, F1 score, precision, and recall. We got about 80%, which we believe was decent because this was our initial stab at modeling. And you can also see the confusion metrics and how does it look like for different observations. Next slide, please. Okay, so now after the training and everything, we did some reflection on our findings of this initial model, and I want to talk out more on that. So reflecting on our model, some of the observations which stood out were, if we clean the data, or if we had just left it just like that, no cleaning, no treatment to it, it did not bring a significant difference in our metrics. We did it as per the best practice, but it didn't really matter. Then TF-IDF vectorizer, although it outperforms if you use a simple count vectorizer, again, the difference in performance was not significant. We also tried another popular classifier called naive Bayes, which you can see the metrics is being compared on the right-hand side table. But we saw, like I said, SVM was our best model, so it outperforms the naive Bayes classifier. Something super interesting for data scientists in the audience, which stood out, and I want to call it out, is the optimal loss function, which came from our cross-validation, was Huber loss, modified Huber for classification, over hinge loss or log loss, which were the other options applied. So now we all know that Huber loss is usually used when you want to penalize certain observations a lot more and certain observation not so much. So when we think about it in our space, we feel that this is the hint for, again, insufficient information in our features for indicating toxicity. So this again brings us to the same point that we need context. We need more context for a particular word to decide if it's a toxic sentence or not. Now, doing some data reflection. So like I showed you guys some of the categories we had in data, we feel it can be a very prominent feature. How? So if you think of an expression, sometimes an expression is a slur given ethnicity or given a discriminatory category. I'll give you an example. So word chap is okay, probably okay if you use it with an American context, but if you use it with an Asian context or Japanese context, it becomes a slur. So that tells you that how these categories can act as a very important feature. And then another column which we had was ID, marker ID column. So like Naoki explained before, the idea of ensemble consensus learning and marker credibility, we are planning to use this ID column for that purpose. Well, that's about it. I just feel it's food for thought for many of you and would love to hear if you have any thoughts on either of these points. Passing over to you.
Awesome. Thank you.
Naagma.
Yeah, thank you so much. I think this highlights, we've made some progress, but we have a lot of opportunities for all of you to join us as well. So I'll hand it over to Anna right now just to briefly talk about some of the ways in which we're applying or we see these applications and then how you can get involved.
Hi, yes. So as you can see, we've identified some immediate applications such as the text-based content to which we're working towards. And we also know there are other future applications where TakeTwo would be impactful. In the future, we do hope to extend to other languages. And in addition, we are working with different partners to realize and co-create this vision to make TakeTwo a valuable tool in our society. Next slide, Naagma. Okay, so as you saw from today's presentation and demo, we have set up a foundation for TakeTwo. And even with our machine learning that we showed you today, it is just the very beginning. This is a complex problem that we're trying to solve, and we have barely gotten started. So the good thing about that is that there are a lot of opportunities to get involved and to help. So we need, many of you today are data scientists and designers, maybe developers, and we need all of your help. We can use as many data scientists as we can. But also, if you know anyone who isn't here today and who is not a data scientist, we're looking for a various skill sets. So anyone who can contribute, maybe a linguist or a political scientist who has experience with racial bias. There's a lot of room here to expand and make this a better tool. We're also open to suggestions and ideas on how TakeTwo can become better and improved further, whether it's the user interface or with machine learning. So we are definitely looking to expand, and we're looking for all of you to help. Really, all and any help would be greatly appreciated. Thanks, Naagma.
Awesome. And so we, I think Upkar has shared our repositories. We have a tutorial set up, and I think I'll also post this in the chat if it hasn't already been posted. But join our Slack community. Here's a QR code to help you get started and set up with being able to join us in Slack. Visit our repository, another QR code, please visit and take a deeper dive into some of the work that you heard about today and the vision that we see TakeTwo going towards, and also share how you feel like you can contribute or ways in which you feel that TakeTwo can be taken as well. So please join us, and we thank you so much for your time and hearing us out today. And if anyone has questions, I think we are open to hearing some questions, any comments, any feedback. So I'll open it up now for anyone who wants to share.
Great. Thanks for the great presentations. I see some questions in the chat. Maybe we can just quickly go through them and just remind everyone. And if you have questions, please feel free to to ask in the chat. Or by the way, when you type in the chat, make sure you select for everyone so everyone else can see the messages, questions. I think by default it's sent to the host, to me only. And again, if you prefer to ask questions, feel free to raise your hand. We can unmute you. You can speak to ask questions or make comments. It's open discussing times.
Okay. I think Sonam Gupta has raised a hand. Okay.
Hi, Naagma. Can you hear me?
Yes.
Oh, perfect. This was a very interesting presentation, definitely closely related to my PhD research topic. So I have been asked a very common question, so I would like to ask the same to you guys and see if you have any suggestions or whatever your answer is. So for you, for this project, it's racial bias. So in general, like, how would you go about measuring bias? Like, if we want to think about how to quantitatively measure it, how would you go about it?
Right. I think what we've realized is that, like we had mentioned earlier, that the getting to a place of ground truth when it comes to something as subjective as racial bias is extremely difficult, and that's where we started to brainstorm a little bit and think about whether, if it's not getting to a objective ground truth, is there something that we can leverage from a community standpoint of consensus around, from trusted experts, from people who have this this background and awareness of the deep societal issues, if we can leverage their expertise and come as a community together to be able to identify examples, be able to collect that together and weigh it against what the thoughts are, and be able to bring that together. I think that's sort of been one of the approaches that we've taken. Does anyone else have any thoughts on this?
Yeah, if I may chime in, I think that's a very important point and a very philosophical point. But I think, and we've thought about this quite a bit. It is a subjective kind of notion, but I think it's also a very fitting notion to apply machine learning, and especially machine learning from crowdsourcing, because after all, there's no one person that can make this judgment, right? It's really up to the people eventually, I think. So it's very interesting. I mean, not just interesting, but important agenda for people working in machine learning. So, and if you want to, continue to investigate this and, work with us or contribute to this project, we'll be very happy to work further, discuss further.
Yeah, definitely. Thank you for answering, Naoki and Naagma. Appreciate it.
Thank you for asking. Is there anyone else who wants to raise their hand? I think we also have some questions in the chat, and I'm also conscious we have 3 minutes left. So if we don't get to your question, please join our Slack channel. Reach out to one of us if you're not able to, and ask your question there too. That way we can continue the conversation there as well. But let's see. I think Zahid. Okay, Arthur Zinger, you've raised your hand.
Yes, for language. Yeah, for languages or cultures other than American English, are there similar or dissimilar patterns for spoken bias?
I would guess that they are similar, but different enough that you would want to train a model for probably for each language if you can. And yeah, it's interesting. It's like Pritika pointed out. Some judgment may depend on some features of the text or the speaker, and it may, I think, it also depend on the language. It may make sense to build a common model that takes the language as a feature, but because you have to, there's so much that depends on the language, you probably would start with separate models, and maybe you can do transfer learning or something, I guess.
May I suggest that you consider the musicality of the language, or the musicality of the speech, such as changes in volume, changes in pitch, changes in emphasis, acoustic emphasis.
Yes.
That's a, yeah. So far our project has focused on textual data, so written. But we want to, as you saw in the applications, we want to expand. So this is definitely something that, as we think further as to when we reach out to getting like vocal, taking into account spoken language, all of that, I think this is a really important point for all of us to consider. Okay. So I think we've hit in the 2 o'clock mark. I don't know if we wanted to hand it back to talk about AI camp and close this out, or if you know,
I
again,
see
please
we have
ask your-
another question. Hi, Zahid. Go ahead. I see your raise your hand.
Yes, so I just actually wanted to clarify, it was a question that's in the chat as well, but it's when you were talking about the TF-IDF part in the machine learning, Pritika, I believe, was talking about that. She mentioned that even if a word isn't frequent in a document, it may still be important. And I was wondering if she or someone would be able to expand on this and clarify, giving examples and talking about how this would be detected and included in determining TF-IDF.
Sure. Yeah. If you can go back to that slide, I can quickly show him.
Sure.
Thanks for asking that question, Zahid. Important thing to clarify. So yeah, like I said, even if it's not super frequent, the term frequency would be low, right? But if you see the other term in the product, even if there are few docs which contain that word, right? This particular term will be high. The log ratio will be high, and that's how if you get a right balance of a frequency and this particular log ratio, your TF-IDF will still be relatively higher value compared to terms which are, even if they're super frequent, they're not important in the data set.
Okay, so you were saying if it's other terms in the product, could you give an example of like the sort of thing of how this would, of where this could happen, or an example just to demonstrate what you mean?
Right. So let's say if you have a bunch of news articles with you, let's say you have 100 different news articles with you, and then you want to classify them into different categories. So let's say if there is inherently a category of sports in your news article, say football, right? So there would be popular words like sports, running, playing. These will be commonly occurring words, I'm assuming, in the news articles, right? So their TF-IDF will be low. Why? Because they will be almost present in all the number of docs. So this ratio, total number of docs, would be 100. Let's say total number of docs are 100. Then the word play, I'm assuming it will be present in 99 documents, right? So this ratio becomes almost close to 1, which is almost equal to log 1 is nearly 0. Right? So this TF-IDF will be very low for a word like play in a sports news article. But word like football, it might not be present in each and every article. There could be articles on basketball, Olympics, whatever. So that word the term frequency will be maybe low for football word, but the other feature, log of the ratio, that this value will come out higher for words like that. And that's how when you do the product, your TF-IDF value will be still higher than common words which are occurring. That's what I'm saying, if it made sense.
That makes sense. Thank you very much for that.
Awesome. Any other questions that anyone has?
I see a question asking about share the previous slide again. I think she or he talked about this slide.
It might have been the getting started. I think this was also in the chat. So.
Okay. Okay.
And if you.
That's great.
Yeah.
Yeah. We probably just going to include the link to them to later on.
Okay. All right.
We still have a couple of minutes. If anybody have last minute questions, feel free to type in the chat, or just feel free to raise hand to speak. By the way, again, when you type it in the chat, make sure select to everyone. I have a question sent to me. They're asking about the REST API course. Is that free to use, or is there any limitations or threshold to call?
Is that the API? The API is free to use and open source, yeah. So the GitHub repo is just there on the screen and in the chat, and it's all open, so you can pick it up and use it.
All right, I think that's all the questions we already covered. Thanks the TakeTwo teams for the presentations and the Q&As with the team. I know this is a virtual event, but I still want to give a round of applause for the team's great effort. If you can turn on your cameras, give the speakers a round of applause, and also you can send the claps or in the room reactions or in the chat. Let's give the speaker a round of applause.